Have you ever wondered why certain fruits like apple, avocado, and vegetables like potato, eggplant turn brown after slicing? Or golden crust bread tastes better than normal? Or the yummy French fries and hash browns to the normal potato? Or the seared meat to cooked meat? It's because of the chemical reaction taking place within food known as food browning. Now let me explain to you what food browning is. When fruits and vegetables are cut, enzymes present in them react with the oxygen in the air to produce brown pigment, which results in food browning or food discoloration. While food browning can be aesthetically unappealing, it is not necessarily harmful to consume. However, it can affect the taste and texture of the food. To prevent browning, you can try to minimize the amount of time the cut surface is exposed to air by storing the fruit or vegetable in an airtight container, or by wrapping it tightly in plastic wrap. Additionally, you can try dipping the cut surface in an acidulated water solution like lime water before storing it. When food is exposed to heat, a natural chemical reaction known as food browning occurs. This reaction is responsible for creating the appetizing brown color associated with cooked meats, vegetables, and baked goods. In addition to changing the appearance of food, the complex series of chemical reactions that occur, and aromas. Therefore, food browning is essential in enhancing the taste and visual appeal of a wide range of dishes. The two main categories of food browning are enzymatic browning and non-enzymatic browning. Enzymatic browning. It refers to the natural process by which certain enzymes present in fruits and vegetables, such as polyphenol oxidase, react with oxygen in the air to cause browning or discoloration of the food. This process occurs when the cell walls of the food are damaged, either by cutting, bruising, or other types of physical damage. The enzymatic browning process can affect the taste, texture, and appearance of the food, and can impact its shelf life and nutritional value. While enzymatic browning can sometimes be prevented by adding acid, such as lemon juice, or by storing the food in airtight containers, it is a natural process that occurs in many types of fruits and vegetables. It is a chemical reaction involving polyphenol oxidase, catechol oxidase, and other enzymes that create melanins and benzoquinones from natural phenols. Here are some examples of enzymatic food browning in different types of produce. Apples. When you cut an apple and leave it exposed to air, enzymatic browning occurs, turning the flesh brown. This process can be delayed by dipping the apple slices in a solution of water and lemon juice or by storing them in the fridge. Potato. When potatoes are cut or peeled, they turn brown due to enzymatic browning. This can be prevented by placing the potatoes in cold water until ready to use, or by cooking them right away. Avocado. Once an avocado is cut, enzymatic browning begins to take place, making it less appealing to eat. To prevent this, store the cut avocado in an airtight container with a slice of onion, which helps to slow down the browning process. Bananas. When a banana is cut or bruised, the peel and flesh will start to brown due to polyphenol oxidase activity. This can be slowed down by wrapping the banana stem with plastic wrap or storing it in the fridge. Overall, enzymatic browning is a natural process that can be slowed down by various methods, such as using lemon juice, cold water, or storing the produce in airtight containers. Non-enzymatic browning. Non-enzymatic food browning is a chemical reaction that occurs when certain foods are exposed to heat, resulting in the formation of brown pigments, flavors, and aromas. This reaction is commonly observed in foods such as bread, coffee, and roasted meats. The intensity of the browning reaction can be influenced by factors such as temperature, pH, and moisture content. Non-enzymatic food browning is an important aspect of flavor and color development in many cooked foods. There are two types of non-enzymatic browning. Caramelization and Maillard reaction. Caramelization. It is a chemical process that occurs when disaccharide sucrose is broken down to monosaccharide glucose and fructose. It is a non-enzymatic browning reaction that produces a complex and rich flavor and a distinctive brown color. The process of caramelization occurs when sugars are heated to a high temperature, causing them to break down and create new compounds that contribute to the flavor and color of the food. Here, pyrolysis of sugar takes place. To caramelize food, you will need to apply heat to a food that contains sugar. This can be achieved by cooking the food in a dry pan or oven, or by adding sugar to a liquid and heating it until it caramelizes. As the sugar heats up, it starts to melt and then break down into smaller molecules. These molecules react with each other and with amino acids in the food to create new flavor compounds. Some examples of foods that can be caramelized include onions, carrots, and sweet potatoes. When these foods are cooked over high heat, the natural sugars in the vegetables break down and caramelize, creating a delicious and sweet flavor. Caramelization can also be used to create caramel sauces and candies, which are made by heating sugar until it turns into a liquid and then allowing it to cool and harden. In conclusion, caramelization is a simple yet effective way to enhance the flavor and appearance of many different foods. By understanding the process and using it correctly, you can create delicious dishes that are sure to impress your friends and family. Maillard reaction. Louis Camille Maillard, a French chemist who first described Maillard reaction in 1912 when he tried to reproduce biological protein synthesis. It is a chemical reaction that occurs between amino acids and reducing sugars, usually through heat, resulting in a series of complex reactions that produce a range of flavors and aromas. This reaction is responsible for the delicious flavors and aromas of baked, grilled, or roasted foods. The Maillard reaction starts with the condensation of a reducing sugar with an amino acid, leading to the formation of a glycosylamine compound. This compound then undergoes a series of rearrangements, fragmentation, and dehydration reactions, producing a range of volatile compounds that contribute to the characteristic flavors and aromas of cooked foods. The Maillard reaction is a complex process influenced by a variety of factors, including temperature, pH, water activity, and reactant concentration. It is an essential process in the food industry, as it is responsible for the development of flavors and aromas in a range of cooked foods, including bread, coffee, chocolate, and meat products. In conclusion, food browning is a natural chemical process that occurs when food is heated. It is caused by the reaction between amino acids and reducing sugars in the food and can result in a desirable flavor and appearance in many different types of dishes. However, in some cases, excessive browning can lead to the formation of potentially harmful toxic compounds. To minimize the risk of excessive browning and harmful compound formation, it is important to cook food at lower temperatures and for shorter periods of time, as well as to avoid the use of high sugar ingredients in cooking. Overall, understanding the science behind food browning can help cooks create delicious and safe dishes for themselves and their families.